Assalamualaikum warahmatullahi wabarakatuh dan very good evening. I am Muhammad Shakir bin Sulaiman from University Malaysia Kelantan. Will be presenting about alluvium assessment of gold bearing layer in buried oil river channel by using electrical resistivity method at Batu Melintang, Jeli, Kelantan. For the introduction, gold is well-known mineral resource that has been mined from Tokmo, Thailand and Kalai, Batu Melintang area for many years. The study area was located in Batu Melintang, Jeli, Kelantan. The rock formation in the study area mainly consisting of metasediment and metamorphic rock of Manga Formation. The electrical resistivity imaging (ERI) survey was conducted to delineate the distribution of sediment in the gold-bearing layer and the nature of bedrock within the study area at Batu Melintang. The objective of this study are to identify the sediment in the subsurface of the mining area and to locate high-potential deposits containing gold. Data is obtained by making a measurement on the ground surface. Electrode configuration that has been used is Schlumberger array. This array has advantage that can help to recognize the layering of sediment containing gold, which then help in effective mining plan. This is the location of the study area, and this is the center of the survey line. This is the urban thermometer LS. This is the mining area consisting of a river within the mining area. Material and method. For survey line has been conducted in the survey area, which is consisting of Schlumberger array. The length of the line are 200 to 100 meter with spacing of 2.5 or 1.5 electrode spacing. Equipment involved with urban thermometer LS, battery, land imaging cable, electrode clip, cable connector, steel electrode, 200 meter multi-conductor cable, GPS and hammer. The raw survey data then will undergo the inverse modeling by using REST2D software in order to obtain the pseudo-section profile. Pseudo-section is stand for the result of the ERI survey. All the result will be compared with the chart that is as a reference table. This table consisting of the value for resistance or resistivity in ohmmeter of rocks. For example, conglomerate, it shown that the value of 10 to higher than 1000 ohmmeter. And then as we can see here, alluvium is ranging from 10 up to 10, not 10, sorry. It is ranging from 10 up to 1000 ohmmeter. So this chart will be used to interpret the pseudo-section. For the result for pseudo-section, first pseudo-section survey line can be seen that there are three channels, main channel in the area. The survey line is conducted for 200 meter with 2.5 meter electrode spacing. Depth of penetration for this survey line is 35 meter. As I said before, we can detect three channels here. The channel depth is average channel depth is around 10 meter from the surface. The location of the channel is safe within 70 meter, 120 meter, and 160 meter from the survey line. This is 0. The left part of the survey line is 0, and this is 200 meter. The right part is 200 meter. The resistivity value, we can see that if it is higher than 900 meter, we can consider it as a hard rock or bedrock, which is elevation around 75 to 100 meter of bedrock. So this is the value. The blue one is considered as a channel. Next is survey line 2. We can see the line also conducted 200 meter length with 200 meter length and with 2.5 electrode spacing. The depth of maximum penetration also 35 meter. In this second pseudo section, we can see there are more channel, but only 3 major channel and 3 others are just a small channel. Average channel depth is around 10 meter also. We also can see the fractured bedrock here, which is shear zone. It's also shear zone. Shear zone also help the formation of alluvium channel. Later, as the shear zone got eroded and the channel can deposit gold in the bed of the river channel. For the neck line is the third line of the survey. We can see there are also 3 channels for this survey line. This survey line only conducted with 100-meter length and only 1.25 meter electrode spacing. This is that means the line is shorter with smaller electrode spacing gap, and that create only 16-meter depth of penetration. 16-meter depth of penetration only. And the channel, as we can see, the channel, the largest channel is on the right of the survey section, which is around 60.5 meter length from zero here, which is here. And this channel is deeper compared to other channel in this same survey section or pseudo section. And the value higher than 900 we can consider as bedrock, which is located around 90 meter to 100 meter. Okay, the third survey line is not third. This is the fourth survey line. The fourth survey line is consisting of also three major channel. You can see the larger blue one. This is the deepest river channel. It extends from here up to here, involving the fracture bedrock and shear zone also. The river channel and 120-meter length of the survey line. You can see here 1, 2, and 3. This is the largest one and the deepest one of all survey lines. So that's the fourth pseudo section from the survey. And from the all the survey section, we can create a simplified version of the result, which display the location of the alluvium. You can see here, first line, second line, third line, and fourth line. We can arrange it in this way. As the survey is conducted like this in the field, in the mining area, this is the mining area. As we can see that there are several ancient river channel here. We can see from the result, and we can join it to make a clearer picture. The proposed river channel in figure 6 show the total large river channel of the survey area. Actually, we just omit the smaller river channel because it is not important. This river channel is suspected to contain the gold content at the back of the river channel. So by using the result, the miner can use it to focus on the mining activity of the specific location rather than digging without a plan. So they can do a focus. They can focus more. They can focus more on this targeted area. This can help to develop more sustainable mining plan as the primary target zone are prominent. For the conclusion, this survey is suitable for the new study, which is aluminum assessment of the gold bearing layer. As before this, it is only used for hydrology and exploration only. So now we can also use it in the gold exploration for alluvium mining. The result of the survey also clearly show the distribution of the channel Finally, it can benefit the miner, enabling them to plan a cost and time productive mining activity as the location, distribution, and thickness of high potential gold bearing alluvium can be identified and focused. Okay, that's all from me. Thank you.